Okay, so what I want you to copy down, we're going to find a pattern. We've done positive exponents, like but now we're going to get into some negatives. This might be new for you guys. And let's also do okay. You're close. It's actually a half. Yes. Yeah. Have you seen that before then? Okay. What I want you guys to do is you should be able, I mean, you can use your calculator if you want, but you should be able to do these just in your head. Fill in all of the positive ones in your notes. So just take a minute and do that first. I shouldn't say that. All these are going to be positive. But what I just want you to do is fill in all the positive exponents first. And we're going to try and find a pattern. Okay? Yes, 2 to the 0. Yes. So I'll give you a few minutes to do that first. And then, like I said, we'll try and find some patterns. Okay, so we've got those filled in. 2 to the 0, 3 to the 0, 5 to the 0. What's that? Good, Tia. Yep. This is half of 8 is 4. Half of 4 is 2. So this should be, if you keep the same pattern going, should be 1. With the 3's, yes, very good. So what I wanted you to be able to see is with exponents, anything to the 0 power is 1. So that's one thing I want you to remember first. If you put to the 0 power, it's 1. Another way to think of it, you guys remember we had those 3 exponent laws? Yep. Like, let me just give you a quick refresher on that. We're using variables. We'll use this when we get into more of our algebra stuff. What are you doing? You're multiplying, and they have to have the same base, remember? So it'd be x to the 7. Because this is x times x times x. This is x times x times x times x. So there's 7 of them multiplied together, so it's x to the 7. Now if you're dividing, let's just say something like this. You minus them, right? So x to the 8th divided by x to the 2nd, that's going to be x to the 6th. Which, if you think of it like this, 4, 5, 6, 7, 8, 1, 2. If you cancel them out, x divided by x, and x divided by x, so there's x to the 6th left over. That's another way you can think of it. Now, if you have something like, the purpose I'm showing you this is, if you have something like, say you did x to the 4th over x to the 4th. If you subtract x to the 0, which is 1. Anytime, when does your fraction equal 1? Whenever, yes, good, Carrie, whenever the top is the same as the bottom, right? That's what we have here. We have x to the 4th over x to the 4th. It's equivalent to 1. Just like 10 over 10 is 1, or 5 out of 5 is 1. 100%. We've been doing, fraction, decimals and percents. If you get 4 out of 4 on a quiz, that's 1. That's 100%. So whenever you have the same thing on the top and bottom, it's equal to 1. So that's another way to kind of help you understand maybe that anything to the 0 power is 1. Okay? Now, if you keep the same pattern going, kind of what Josh was talking about, 2 to the negative 1 would be a half. You keep cutting these in half. If you cut that in half again, you're going to get a fourth.
An 8.
Good job.
16.
Good job. You got it.
64. 128.
Good job. Okay, over here it would be
1/3.
1/3. What's a third of a third?
9.
A 9. Over here you'd be
10. 1/5.
Boy, Brian, you're impressing me here, and now you're losing me. 1/5 and then 1/25.
I said 1/5. Yeah, you did that.
Did he? Okay, I thought you were.
One of the first ones you said.
Okay. Now, here's the idea, okay? Anytime you take a number to a negative power, so say even if you take something like 7 to the negative 2 power, the negative number, we use that in math, that means the reciprocal. Do you guys remember what the reciprocal is? Like, what's the reciprocal of 2/3?
6 9s.
No, if you do 2/3, what's the reciprocal of that? No. Reciprocal just means flip it. So the reciprocal is 3/2. Okay? The negative exponent does the reciprocal. So, in other words, we know that 7 squared is what? 49. If you take the reciprocal of that, what's 49 as a fraction?
49.
So what's the reciprocal of that? 149. Or if you want to think of it like this, 1 over 7 squared, 149. Okay? So if you do 6 to the negative 2 power, we use that in math to represent 136. Good job.
Good job, Josh.
Say if you do it's a little bit bigger number. Anybody know what that is?
124.
No, I am. 1/3 is okay.
136.
2 to the third is 8.
20.
It is
1/16. Good, Tammy. Yep, 1/16. Okay. Now, we're going to use this power, and we're going to use these negative exponents now. You've done scientific notation. I'm sure you're probably in scientific notation with super small numbers. We've done really big numbers. Now we want super small numbers. So, scientific notation. Okay. If you're doing something really, really small, Anybody remember from like science class what that would be in scientific notation?
No. 100,000.
4 to the negative. The negative 6.
And 10 to the negative 6.
10 to the negative.
Good job. Remember, you have to have one. It's got to be a number between 1 and 10. So you got to have basically one number there. And then you move it back 5 places. Now, you guys, here, see if you're following what we're doing, if you understand it. If I were to write this a different way, just so we understand kind of the mechanics of how it works, 10 to the negative 5th. Can anybody tell me what that represents? No, I mean from what we were doing over here. 10 to the negative 5th. What would that be just by itself? Well, you almost said it correctly, Steve. Remember, it means the reciprocal. What's that? What if guys, what if I did over here something like 10 to the negative 2? What's that? 1/100th. What's 10 to the negative 5? Well, we want, there's going to be 5 tens, so there's going to be 5 zeros. Which, if you multiply those two together, what would you get?
You get 4 times 10 to the negative 5th.
6. 10 to the negative 6.
Isn't it?
Well, how could you change 4 into a fraction form? 4/1. You multiply the tops, you multiply the tops, you multiply the bottoms, and multiply the numerators. Good job. Yeah, yep, 4 over 100,000. Which, guys, 400,000ths is what this was. Tens, hundreds, thousands, 10,000s, 100,000s, 400,000ths. I just wanted to show you how this negative power works, how to make the correlation between that stuff and scientific notation. Do you guys follow that? Because we're still gonna be kind of converting between percent, decimal, scientific notation. We're kind of converting between all different types so that you get more familiar with them. There was 10 to the negative 5th, so you need 5 zeros. Okay. Now, if I gave you, let me put another example up here. Say I gave you, let me make it a little smaller just so it's easier to see from where you are. Could somebody give us that in scientific notation?
25.
Hold on. No. Need a number between 1 and 10. Carrie, you want to try it? No? Tammy? Say that again. To the negative 3. Good job. Very good. Okay. I don't know, Brian, I might have to pull your Math God card. We might have to. You might be losing your membership. Okay. What I want you guys to do is open up to that. It's page 131. 131, and I want you to write out 1 through 12 there. We're going to use these for practice, and then we'll work on our homework. So write out your answers for 1 through 12. Not yet. Okay. We'll do this practice, and then if you guys need to go to the bathroom or something, you can go. So do these first.
No, I'm done.
You're going to be done.
Class? Or with life?
Well,
After you're done, it's the same thing I'm doing with life.
let's see. Okay. But you guys give me the answers. Okay? Jason, what do you got for number 1? Brian? Well, as a decimal, I think that would be, but it says to write it as a fraction. 1/36. Okay. Number 2, raise your hand if you got it, just so everybody gets a chance. Brian?
No, I know.
I got it.
Josh?
1, 2,
I didn't know it.
Okay. Number 3, Nathaniel? Nice job. Okay, number 4, Zach? 729. Okay. Now number 5, it says write it in exponential form. When you see exponential form, it's got to have what?
Just
It's got to have an exponent. Okay, Brittany? Good job. 3 to the negative 5th power. Let me write that better. 3 to the negative 5th power. Good job. Tammy? Very good. Okay, so it's basically the opposite of 1 through 4. You're just working backwards. Number 7, give it in standard form, so now just give me the number, basically. Josh? How many zeros? We need, yes, 6 zeros. Because you're going to move it back past the 7. Sorry, you're going to move it back past the 6, and then you need to go 6 more times, so you're going to have 6 zeros. So then you need the 6876. Very good. Okay. Number 8. Okay, Tammy? Nice job. Very good. Number 9 in scientific notation. Okay, Tammy? Yeah, because we have 7 zeros, and then you still got to move it 1 more spot, so to the negative 8th. Okay. Number 10, Jason? Very good. Okay, number 11, Jeff? Very good. Yep, you guys got it. And the last one, Brittany? 7 times 10 to the negative 8th. Very good. Okay. Guys, any questions on how you do those? we're going to do, before we do our homework problems, we're going to do some of the homework problems together in a group. So what I'm going to give you is I just copied some of these onto a sheet to help you out a little bit. So let me just